Right, so today I will be explaining text summarization. And when I say summarization, it's either extractive, which is very easy because you're just using a subset of your sentences, very, very easy. There's no need for paraphrasing and those complex things that humans do. And there is another thing which is abstractive, which is very elegant, it is very artistic, very beautiful, and writers use that. If you have read beautiful novels, you will see that we're using abstractive thing. And why I'm talking about pointer generator networks? Well, I have explained CopyNet in my YouTube channel, but pointer generator networks, although it is very similar to the idea of CopyNet, in the sense that it copies some of the words from the source because they are out of vocabulary, or we want to do it fast without getting involved with lots of probabilities. But the other thing is that pointer generator network has a good feature which is called coverage. And it has a coverage loss as well. So coverage, it means that when you add those attentions till time t, it means that what context or what set of words have already been considered. And so in some sense, it is similar to CopyNet, which I've explained on my playlist, on my YouTube channel. CopyNet, very similar idea. But here we are using pointers. And so let's see what is this article about. And so the contribution is that they use a hybrid pointer generator network that copy words from the source, just like the article of CopyNet. It's very similar to that. But now we are using pointing, which aids accurate reproduction of information. And second, we use coverage. As I said, when you sum those attentions, we can understand where we are in our milestone. So our hybrid generator network facilitates copying words from the source text, which improves accuracy, handling out of words, vocabulary words. You know, do you have some word out of word vocabulary? They are in the source. So if this is in vocabulary, some of them have intersection. So some of them, so these point, for example, can be found on the source, and also it can be found on the vocabulary, so we can generate it. If it is on the source, you can copy it. If it is on the vocabulary, you can generate it. And so we have some text. This is summarization. We have some text, and we want to summarize that. Well, pointer generator networks summarizes in this paragraph. But pointer generator with coverage, if you read this paragraph, you will notice that it's a slightly improvement of the previous version. And of course, our baseline here in this article is just a traditional sequence to sequence and attention. Which sometimes get repeated, and we don't like this phenomena. But this coverage removes this repetition in a beautiful way. And the data set is, if we can download this CNN Daily Mail data set. It's an interesting data set. And so this is the baseline. This is what you already know, because it's just encoder, decoder. You have the source is coming, Germany emerged victorious, and the summarization is here. And we always start with start token to tell the decoder that this is the start of the sentence. And this is the summarization that you write, and because you want to learn it. And here you see the probability beat. Germany beats, so the next word is beat. Beat is here. Germany beats, and you predict what is the next word, and so on. And use the context vector, which is linear combination of your hidden representation, and you create context vector, and then here, so everything is like this. Here you have energy. Some people call it alignment. In the original article of Benju Yashu, they call it energy. And then you have attention vectors. You use attention vectors to create the context vector. Instead of HT star, it's better to say CT. And then softmax we use softmax to create the probability. And this is the probability we generate in traditional way. But the pointer generator network, which is depicted in this, it uses P generator. So we should use this formula. So we are using P generation, and 1 minus P generation. So if P of probability of generation is high, for example, 0.9, then this term is lower. The more it gets higher P-gen, then it reduces 1 minus P-gen. And it reduces the effects of copying. This is, for example, the effect of copying. And this is your vocabulary that you are generating in the traditional fashion. So there is a trade-off between what you want to, this vocabulary, and what you want to copy. So an extended vocabulary, as I said, we have some words from source that are sometimes out of vocabulary, but we have some words from vocabulary. And as you've seen in if you've seen the paper of CopyNet, which I've explained on my YouTube channel, there could be an intersection, and when some word is in the intersection, it means that this word can be generated like the usual way of vocabulary, but it can also be copied. So the pointer generator networks, the probability of that generation, this generation, depends on some factors. You can imagine that it could be a decoder input, X. It could be decoder output. These are learning parameters. This one, and this one are learning parameters. And this is the context that it's better to use CT, as I said. And then here you create, now I see why they didn't use that. Because they wanted to use coverage vector, which is the same C for context, C for coverage. They are different things. So that's why they prefer to use that H star. Okay, so CT is defined in this paper as a coverage vector. And so you see, when you are teaching, you understand something very deep. And that's why teaching is interesting. The coverage vector is used as extra input to attention mechanism. So changing equation 1 to this. Because we are using this traditional way, but also we are adding the coverage and its weights. And then we use the coverage loss because we want to minimize, this loss to be, because it's some of the attentions, we don't want one word to get repeated several times. That's why it keeps track of that and controls that in order to avoid it. So this is the loss. So not only you're using the generation, but also you want the coverage to take care of it. And in summarization, we have interesting parameters. We have different. If you look at the Wikipedia, there are many different definitions, different measures. Different measures, and each one can capture different, because summarization is complex. So it can capture different measures. So in pointer generator coverage, they have improved that. You see, 39 and 17 is bigger than 15 that you use pointer generator, and it is even better than this baseline, which was very bad around 11. And also everything has been improved. 28 has been improved by 36, and so this is the article that they gave you, and this is the reference, and they say, can you predict this reference summary? Can you predict some reference summary? But the problem with summarization is that it needs supervision, lots of supervision like this. So it is still on its infancy. But there are also unsupervised methods that I will explain. They are, for example, using some kind of autoencoders. They're really interesting. And I prefer them because if you do supervision, it's so weird. Because for example, my niece, she's 4 years old. She doesn't need these labels in order to understand what is a summary of some words, some sentences. So it is an internal mechanism. She doesn't need to know what is the concept of summary. And so the baseline is this, the pointer coverage, pointer generated, but no coverage. But if you add the coverage, you see, you don't need to repeat some more any instance and up until what direction, until what point in the sentence you have done some kind of summarization. And as I said, we have two kinds of summarization: extractive summarization, which is not difficult. You just include subset of sentences. But there is another thing which is artistic. We call it abstractive. For example, writers of big novels. For example, I've written a fiction novel. I used abstractive. Everything that I used was abstractive. So abstractive, we use lots of paraphrasing. Your sentences are beautiful, artistic. And so human tends to do abstractive. But machines just pick some random, or not random, just pick some subset of sentences, and it is extractive. But this pointer generator with coverage, it's so strange because it uses a combination of both of them. So it's beautiful. So but the bad thing about this article is that it needs supervision. So you need to learn a lot of things, and it's not problem. It's because supervised learning. We are very good at supervised learning. We have created very interesting idea, CopyNet, pointer networks, this article, CopyNet generator. There we have lots of articles that need supervision. Even in parsing, you have lots of papers about supervised approaches to parsing, even either dependency parsing, semantic parsing, constituency parsing, discourse parsing. All of them needs lots of supervision, but in real world you don't have tree banks and so on. So you see that so this summarization in NLP community can be improved by introducing newer unsupervised methods such as variational autoencoders and so on.